Hello, my name is Marc Borrett and I'm the CEO of Reactive Technologies. We are a leading grid enhancing technology company helping power grids around the world manage safely to transition to a high inverter, high renewables power system. We have developed a number of world-first energy measurement services. We have built a very large patent portfolio for these new technologies, and we are delivering significant results for countries that we work with. In the UK, we have found more than up to 30% additional capacity for the grid operator to use more renewables safely. That is saving the UK 18 million tons of CO2 every year, which is the equivalent of 5.5% of total UK CO2 emissions. We work across the world. We have customers in Asia Pacific, which we will talk about later. We have customers in the Middle East, and now we have many customers in North America as well as Europe. So as a power system changes, as more renewables are installed, the physics of the power system changes. Unfortunately, people only really think about the first two stages of the power transition, building more renewables and then connecting more renewables. But the big challenge actually comes from operating a power system with high proportions of renewable energy. Building and connecting renewables is very understood, but operating is not. And when you have high renewables, you have less stability, and that becomes a challenge for the power grids to safely manage and maintain reliability. So power grids critically need real-time visibility when they have more renewables. This is because synchronous generation, large power stations, provide a lot of stability. As they are taken off the system, there is less stability and the grid operator has less time to deal with a sudden shock on the system. Reactive provides a measurement overlay. We put a measurement system in a country that supports existing measurement infrastructure like PMUs or phasor measurement units. And this measurement system gives ultra high resolution and leading direct measurement accuracy of critical grid stability phenomena. The inertia of the system, which tells a grid operator how much their frequency moves. The system strength of a system, which says how strong the voltage is in a particular area. And also the ability to detect and locate really quickly oscillations, which can be very damaging for power grids. With real high accuracy data, grids can make better investments. They can reinforce their networks more cost effectively by using real measurement data to make those decisions. They can make better policies, and they can reduce the amount of renewables that they curtail, and they can make better decisions to maintain the reliability of the system. And we provide this as a complete turnkey solution. We install the measurement system, we manage it, and we operate it. And we can stand up a live service in less than 3 months. It is a fully secure ISO 27001, fully end-to-end encrypted system that we deliver through the AWS platform. And just to help you understand how we do it, we use something like a sonar system, but actually we send power into the grid. We inject a signal of power into the grid that our measurement devices can minutely detect and see how much of an effect that tiny injection of power has had on the total grid system. And then we can provide that as data into the control room. either through a UI or through a software interface, for the grid operator to use that stability data to make better operational and planning decisions. And so, to summarize, we're able to provide ultra high resolution understanding of frequency, and when a power system or an event happens on a power grid, we can give real-time direct inertia measurement, and we can forecast how stable the power system will be. We can monitor and locate oscillations on a power grid, and then we can give detailed understanding of voltage in particular regions or substations, or even down to individual sites on the power system. And that can be real-time, on-demand measurements. And lastly, with all of this data, we can start to show a power grid how their nadir will look. If they lose a power station, how fast will frequency fall? We can give that visibility all with one measurement system. Thank you.
Marc, thanks very much. I'd like to move this into a little bit of a discussion now, to dive into some of the fascinating points you touched on, and also to talk about Japan. So again, thanks very much. Really interesting. I'm actually not from the power industry, and so conceptually, I kind of understand how renewables might introduce instability into the grid, but how might you explain this to a sort of non-energy industry native?
Yes, I can fully understand, Noel. The analogy that I think is the best one to use and most helpful is when the power system was just being run on, say, coal, gas, nuclear, for example, in the control room of the grid operator, it felt like they were in a steam train. So the power grid felt very big, very heavy, and it took a long time to start up and a long time to slow down. So it would just keep running. It would stay very, very stable. But as the big power generators, like coal-fired power stations, have been decommissioned and taken off the system, they've been replaced by these solar farms and wind farms that are producing energy in a very, very different way. And that means that the power grid itself has started to move away from being like a train to now being something closer to more like a motorbike, where suddenly you have a very fast accelerator. You can speed the frequency of the grid up, slow it down very quickly, but also you could easily stall and the bike can fall over much, much more quickly. And that's because the physics changes. You no longer have assets that are helping to stabilize the grid, like the big power generators. You now have assets producing energy that just react to the weather, and they can't change their output, whatever the grid needs, because if the weather isn't supporting that, then they just can't change their output. So that's why this stability becomes a bigger and bigger issue for all power grids around the world.
That's really helpful. That makes sense. So in a sense, the old sort of gas turbines, coal turbines, they had a sort of almost a buffer sort of built into them. Whereas as we move to these renewable assets, that buffer goes away. Plus, as you mentioned, you can't control the weather. And so you've sort of got various different aspects of instability introduced. That makes perfect sense.
Yeah, you've identified the exact part that provides that stability, the turbines in those big generators, because those spin at 3,000 revolutions per minute, and they store an amount of energy. And it's that store of energy across all of those turbines, across all of those big power generators, that actually give the stability to the grid. And as those are taken off, that stability starts to drop and reduce.
Makes sense. So this is obviously it's a global issue. I mean, it's great that we're moving to renewables. You know, it's great for the environment, but it's something we have to manage as we move forward in this energy transition. And Japan is no exception. And in fact, I think last month you announced a partnership with Hokkaido Electric Power, which is obviously the first, I think, big announcement in Japan. Very exciting.
Yes.
Could you talk perhaps a little bit about the partnership and what you expect to be doing with Hokkaido in the future?
Yes, of course, Noel. Well, Hokkaido, as you say, are very forward-looking. They have a goal to become net zero by 2050, and they are experiencing exactly what this image that we've just been talking about shows. So they have now a large amount of wind, they have a large amount of solar, and they also are now looking at storage, grid scale storage. So all of a sudden, their power grid, the component parts of the power grid have changed quite a lot. And they are seeing that in the actual operation of their grid. And they want to make really good decisions. And to do that, they recognize that they need more data. They need to understand their power system at a much, much more granular level, so that they can optimize the location, the size, the number of different assets that will go onto their network, which ultimately will benefit energy consumers. So the better they can understand how the power grid is changing, the better they can make their investments and the better they can serve their customers. So it really is a great partnership. We're delighted to have HEPCO as a customer. And they also saw that they could get this data very quickly. You know, they want to make decisions, but they don't want to wait many years to install measurement devices and get the data. So we have a very, very fast delivery capability, and we've been able to give HEPCO data very quickly. Already they're using this data. They can understand the grid at a much, much deeper level, but more accurately as well. And this is starting to give them a basis for making those better decisions for the future.
Makes sense. It's great to see that announcement. It's still quite fresh. Thanks for that. So I guess if we take a step back, you know, there's actually more happening in the electrical grid market than just increased adoption of renewables. And the big topic, of course, these days is AI and AI data centers. And so this almost seems to be, from my perspective, be a crazy challenge, because on one hand, operators have to and want to decarbonize and increase renewables for various reasons, but at the same time, they're seeing this sort of growing demand for power coming from these huge data centers. How do they thread that needle, do you think?
Yes, I would almost say, if you think about the renewables being energy transition 1.0, now with data centers coming on, it's energy transition 2.0, and the two things come together. So not only have you got a less stable grid, but now you have, as you said, Noel, these huge assets now that are being built in data centers that consume extraordinary amounts of power. That energy demand is very variable. It depends what they're doing, whether they're training models or responding to queries, or mining Bitcoin, whatever it is. But there is a sudden surge, and also there is a challenge emerging, because the quality of power that a data center wants to use can be different to the quality of power that the grid operator is able to give. So something that would be considered a very normal thing on a power system, like a fault, a voltage fault that just is normally being cleared by the system, that will look like a risk to a data center, and their systems will disconnect them from the grid, because their systems tell them that could be a reliability issue. And so the grid operator now faces a double challenge. A, they have to keep the grid secure with the renewables, which we said is already difficult. But now, just in the normal operation, they have the risk added onto them of data centers suddenly switching off, suddenly losing demand that they thought was there, and at a really big scale. So grids have always used to manage their grid by looking at, well, can we keep everything stable if we lose our largest asset on the grid, which often was a nuclear power station, 1.4, 1.7 gigawatts, for example. Data centers are now being built, each one up to 3 gigawatts. There are others now actually being built that are getting to 5 gigawatts. So this is now not just one big thing coming off. It looks like 2 or 3 nuclear power stations suddenly coming off the grid. And this really is a big challenge for the power system. And data centers are being built at a faster rate than grids can be reinforced. And again, that starts to point to needing more granular data and fast. You need that data in real time. So the grid operator can hopefully start to make, as I said, better operational decisions, keeping the frequency more secure, or investing in particular regions of their network where voltage is becoming weaker. But also, things like oscillations, which I touched upon earlier. Oscillations are when the frequency suddenly develops a very damaging component to it. And that damaging component can directly harm inverters and transformers. So as the whole power system starts to become less stable and there are more stresses put on it, it starts to have more, worrying signs that, again, it's about speed, finding the problem, fixing the problem, investing in the right part of your network to give you the best way of solving that issue the fastest way possible.
Got it. Thanks. Yeah. So we've touched on both sides. We've touched on the sort of supply side and some of the instabilities that can happen there, and now on the demand side in terms of these huge assets, as you say, that are essentially drawing the same amount as a small city, and very quickly over time, very quickly changing over time. So, got it. We're a little bit pressed for time, but just to finish, I would like to touch upon the Japan angle, because obviously the audience is a Japanese audience, and you're a UK startup, and this is a scale up, I think. This is a great example of a partnership. But how do you see working with Japan going forward, and what do you think Japan has to offer as a partner, and how would you like to sort of work with Japan in the future?
Thank you, Noel. Well, we see Japan as a very, very important market. It is an island, so our work in the UK has told us that the grid operators have to be very forward-looking. They have to, because they don't have many other grids around them to help them manage these issues. So they have to solve the problems themselves. And obviously, Japan has got a great track record in renewables, has a vision for net zero, and obviously it's a very forward-looking investor in data centers. So for us, it has all the ingredients where our solutions can make a huge, huge difference. And that's really why we want to deepen our relationships in Japan. We really want to see that we want some close working relationship with Japanese partners who actually are involved deeply in the industry, who maybe build renewable assets, or who maybe build grid scale battery storage, for example, where this stability is a key requirement for their business as well. We believe that could be a very helpful collaboration together, and now is a really great time to start to to develop those partnerships, we feel. And obviously our work with Intralink is very important, and we would hope that if anyone is interested, that they would be able to contact the Intralink office to express their interest, and we would be delighted to follow up.
Thanks, Marc. Yeah, so audience, if you're listening, get in touch if you'd like to know more about Reactive and are interested in working together. Marc, I'd love to chat more. I think we're up against the time limit, but it's quite early your time, so thank you so much for joining. And
My pleasure.
yeah, thanks very much.
Thank you very much, Noel. And yeah, thank you to everyone who's been watching. Thank you.
Cheers.